Ladies and gentlemen, today we have a Ford Ranger. It's a dual cab, four-wheel drive, 3.2 liter turbo diesel, 2013-14 model, somewhere there. Alright, problem with the car is the four-wheel drive light. Okay, so nothing's coming up at the moment. You start the car, right? Alright, you start the car and then you just wait for it, and sometimes you have to change gears. So I'm just gonna change. This is an automatic transmission, so I'm just gonna put it in reverse. So as soon as you put it in reverse or change gear, see that light's flashing in the dash, the four-wheel drive light flashing, right? Also here you got that gear and with the I explanation mark sign. So this is the issue with the car, and you cannot select four-wheel drive at all. So right here is your four-wheel drive buttons. So if you change that right to 4 low, 4 high, 2H, nothing changes on the dash, and you can't engage four-wheel drive on this car. I think that's what the customer said, right? Alright, let's diagnose this car, guys. Alright, just turn the key on. I will I've already scanned the computer, right, and I found under, let's come back in, just under the where'd that go? Diagnostics, just I scanned the fault code, right? This is under the PCM, guys. Okay, I think they have a PCM that's also controlling your four-wheel drives, transfer case and all that, and that's the fault code we got, guys. Mechanical transfer case 4x4 switch circuit short to battery. Okay, let's diagnose this car, guys. Now we can go to live data. Okay, and there's a couple of data we can see there for four-wheel drives. I had a quick look, not much data. There's no separate four-wheel drive transfer case computer for this. There's a TCM doesn't control the transfer case, looks like it. I did have a quick scroll, but all I did found here is this one here. Four-wheel drive switch circuit short to power, right? And if I go and move my buttons here, four-wheel drive, two-wheel drive, nothing changes on the scan tool. So that's the problem we're facing here, guys. Okay, so let's go back to trouble codes. And trouble code says mechanical transfer case 4x4 switch circuit short to battery. The switch is this, I believe. This is what we're looking at, the switch. Okay, so I would say let's start all the testing right here on the switch itself. Got the covers off pretty easy. Just pull it out, couple of clips there, right? Put it aside, and I got the switch off too, the four-wheel drive switch. This just plugs into there, just like that. Okay. I do see a bit of a corrosion in there, in that plug. Could be our switch is bad. It's already looking like there's some corrosion damage there. But while I'm here, I'm gonna do some testing and I'll show you guys how you can test this stuff. Okay, this could apply to many things. Lot of electrical switches. So this is basically an electrical switch, right, guys? They all pretty much work the same. Okay, not saying all of them, but most of them I've seen on modern vehicles, they all work the same. Okay, now we got 4 wires in this plug, right? So let's see what kind of voltages, powers, earth, what do you get here? Okay, guys, so I just got my power test lights up here somewhere. Let's have a look. All right, I got my test light right here. So I'm just gonna connect this to battery positive to make my test easy. I just got my cigarette lighter connector, coming power and negative and positive in these two leads from the cigarette lighter. Just a jumper, sort of kind of like a jumper lead I made for easy testing. All right, just a cigarette lighter to that. Now let's see if there's any earth, any power, whatever we see. Turn the ignition on, right? So I'm just gonna go here and trying to, I might need to back probe it. Okay, I'm just gonna quickly touch my, put my probe on my end of the test light, connected to battery positive at this stage. Let's just verify our test light works. Okay, my test light is working. I'm just touching the cigarette lighter ground there, guys. All right, so I got 4 wires, brown, white with the blue, white with the brown, and black. Okay, 4 wires on this connector. So I'm just gonna quickly see what sort of voltages, powers we get here. Okay, I got nothing on that brown wire. I got nothing on my white with the blue. Okay, I got earth on that brown, white with the brown, and I got another earth on that black. I say we got 2 earth, the white and the black on the far left is my earth. Okay, now let's hook my test light to battery negative. Just make sure our test light lights up. I'm just going to touch the power on that red lead there. Right, my test light works. Now I'm going to look for powers, if there's any powers, anything in there. Okay, so I got nothing on the brown, nothing on the white. So other 2 wires is grounds. We already verified that, so I got no powers there. Now computer switches gonna have power, the 12 volt, sometimes 5 volt. They can work with 12 volt or 5 volt. A lot of the time they will send 12 or 5 volt bias voltage, or for that regard it could be any voltage level, doesn't matter, but most I've seen is 5 volts and 12 volts. So if you put your test light, the test light is too heavy. If you know how the reference circuit works, go watch all my fundamental videos, right? There I explain everything what happens inside the computer, why you don't have the test light lighting up here with your reference voltage. Obviously, if there was a 12 volt reference voltage, the test light is not going to light up because it's too heavy. Okay, because you're going to have a lot of voltage drop. So the test light does not get that straight 12 volt. That's why the test light not lighting up. If it's 5 volts, this test light not gonna light up because this test light only supports 6 to 24 volts. Okay, guys. For that reason, we're gonna have to connect scope. My scope lead here connected to channel A. I'm just gonna go and find the alligator clip. I'm just gonna put that onto the battery ground. In this case, we got this setup here. All right, I'm just gonna connect that to battery ground. And now whenever I find 12 volt, I'm gonna just go and open that scope up. Let's do a measurement. Let's go scope. I'll just set it up. This is going to be very slow signal, so we'll just keep it at 1 seconds per division. Okay, maybe let's go plus minus 20 volts. I don't know what kind of voltage it's gonna have. All right, so every time I find earth, you're gonna see on my scope, it's gonna jump to 12 volt. Let's just test it out quickly. I got 12 volt in this red from the cigarette lighter, red alligator clip. When I touch the alligator clip there, 12 volts, see my scope jump up to 12 volt. We know all our connection is good, our scope is working, right? Now let's go and see what type of voltages we got on these two. We know the 2 far left hand, black and the white with the brown, is earth. Let's go and have a look on what we have on this brown wire at the very far end. Okay, we got nothing on the brown wire. Okay, now next to it is a white with the blue, and I got white with the blue. I got 12 volt there, battery voltage. Okay, white with the blue. So see right here we got 12 volt, right? But if I put my test light, which will light up if I find the power, right? Even if it's 12 volt, if I touch it, it's not gonna light up. And you can see on the scope, I'm dropping all that voltage to almost ground. Okay, so do not get confused. You need to know which tools to use for different testing when it comes to diagnostic. So 12 volt, I would say that's my reference voltage coming from the engine computer. Okay, in this case, from the module anyway. Now on the other one we got nothing, so I'm not sure what that is. So I got no earth, no power, no signal, nothing there, right? You can see on the scope on the brown wire at the very end, I got nothing there. To me, I think what that's going to be is, it's going to be, I'll just back probe that properly. It's going to be my light, illumination for the switch. So the switch at night time when you turn the headlight on, the switch gonna need some light, right? Backing light. I think that's why we're not seeing anything, because our headlight is off. So let me go and turn the headlight on. That's my headlight on. See my scope jump to 12 volt. Now if we go and find earth, if we go and find power, on my test light, on the same wire, see this time the test light lighting up, and on the scope it's staying at 12 volt, nothing's dropping. So that's a straight power. Okay, this is not a computer reference, this is not a computer bias voltage. Okay, so that's my illumination. I'm pretty sure that's what it is. Okay, so what's going to happen here is one ground and one earth. One ground, sorry, I don't know which one, but one of the ground out of two, we already verified that. And that power, when you turn the headlight on, going to be solely for the light on the switch at night time when you turn the headlights on. Okay, now we're down to two wires. See, I don't need any wiring diagram most of the time, okay guys, to do this type of test. If you know the fundamentals, you can do a lot of testing and cars without looking at the information. Okay, now we got two wires verified, maybe let's say 3 wires verified, and we got one more wire which is gonna be our we said 12 volt reference from the computer. And every time I touch it, you can see on that white with the blue wire, that's a, 12 volt reference, because our test light is not lighting up. If you put it, I'm dropping that voltage down to 0, you can see on the scope, and test light is not lighting up. That's 100% coming from the computer bias voltage. Okay guys, I get every time I get mixed up bias and reference, but you know what I mean, it's a bias voltage, right? Now how this is going to work is, before that already, just by checking that, we already verified all our wires are good up to here. Okay, we already verified that. There's no need to check for powers, earth, computer, nothing at this stage. I mean, more than likely, because we got everything that we need to see here, more than likely the problem is the switch. Okay, if it's gonna be a quick diagnostic, I would say that's it, we need a new switch. But just for learning purposes, I will go further and teach you guys more stuff here guys. Okay, now how this is going to work is, the 12 volt and the earth, 2 wires, that is going to be our switch control. So every time you turn the switch, let's say in this case, every time you turn the switch from 2H to 4H to 4L, right, we got 3 variations here, 3 different positions here. What's going to happen is, one side of the switch going to have earth coming in, and you're going to have different register in there, different value register on each position of the switch, and that's going to short that 12 volt reference coming from the computer, and that's going to drop the voltage in the computer. So let's say if it's 2H going to be your let's say 2H going to be your, let's say 12 volt, when you put it in 4H, right? Or it can't be 12 battery volt because we got battery reference, so computer will never know if it's connected, not connected. So let's say this is your 9 volt 2H. If you put it on 4H, it's gonna be like 5 volt. If you put it on 4L, it's gonna be like 3 volts. I'm just giving you an example. That's how the computer is gonna know which position you are selecting as a driver. Okay, that's this very basic principle how it works. Now, we already verified all the powers, earth, bias voltage, everything is here, right? So we only focus on 2 wire, like I said, 2 is just for lighting. So what we can do here, guys, is we can short these 2 wires together. Okay, it's absolutely fine to short this wire together because that 12 volt is coming from through a register inside the computer, so you're not gonna hurt it. Okay, I'm gonna just show you that quickly. Okay, all right, so if I short these 2 wires, let's grab doesn't matter which earth you grab, it's the same thing, and the other side, and we said the second wire, the white one from left from the brown here. I don't know if you guys can see that on the camera or not. Let me zoom it in a little bit further so you guys can see a little bit better. All right, so right here we got earth on that black wire. I'm just using a jumper lead, there's nothing connected in between, and I'm just gonna put that 12 volt into that second wire, which is, we said, the bias voltage. Okay, let me grab a good connection here, let me back probe it properly, right? Okay, now what we're doing, we're shorting out that 12 volt bias to ground. And if I go back to my scan tool, right, we're still showing short to battery, right? Let's me turn the key off and on. Let reset that fault code, and I'm gonna read that fault. Okay, that fault code going to change because now we're shorting out. Ford and Mazda takes too long to scan. I don't know why. When you're reading fault code, it just always takes too long. I tried different scan tools and they all does the same thing. It's just a slow communication. It's not scan tools problem, I don't believe. I think it's the car's manufacturer, computer's problem, the communication problem. Now you see that at the top you got battery short to make transfer case switch short to battery, right? And we got now new fault because we shorted, but I was expecting to see shorted to ground, but it's not showing me. Okay, let me just clear that fault quickly. Now I'm going to cycle the key, maybe even start the car. I'll just change the gears, just let it do its check. The computer will do its check, right? Let me read the fault now. This one's showing me, just turn the car off quickly. This one's showing me mechanical transfer case switch circuit failure. They didn't show me it shorted to ground for some reason. Most of the time if you do that, that would usually short it to ground because we're dropping that 12 volt to ground. Well, let me try something else quickly here, guys. Instead of going directly, I'm just gonna use my test light, give it a little bit of resistance there, see what that does. So all I'm gonna do is connect my just test my test my connection here first, make sure everything is good. What I'm gonna do, on the other side of my test light I got earth coming in, okay? So all I'm gonna do is I'm going to short that pin, the bias voltage, with this test light, and let's see what kind of fault code we get here. Okay, I'm just gonna make sure my test light lights up. My test light is connected to battery negative. Now I got earth traveling through the coil and through the resistor in that bulb onto that tip. I got earth, so I'm just gonna touch and back probe that signal wire now, and let's see what kind of fault we get. Okay, maybe the computer didn't like me shorting out directly, but usually that test should work, but it didn't work for this car. I don't know why, but I don't have any manual information really. I'm just going by just experience, looking at the wires, judging, make my own judgments here, guys. So this will help you diagnose car faster, quicker, and if you practice this more a lot of the time, you can get away with without having to look at the wiring diagram. That's my aim here, guys. That's my mission. Okay, now have a look. We got a new fault code here: mechanical transfer case switch, short to battery. Okay, that's the same fault code we had before. Short to battery. Okay, let me just erase that fault quickly. Read the fault code again. I'm still touching that pin with my test light, guys. I'm holding it there. All right, for short circuit, I don't think they have a fault code for that. I don't think the engineers put that fault code for short to battery in that in this design, but a lot of the time, like I said, this type of test should work. Okay, but anyway, let's go back now and let's just read that fault code again. And I'll just explain to you one more thing quickly here. Now that switch circuit failure fault code's gone. Now we got the same mechanical transfer case pole drive circuit. I mean, that's the same fault. Sorry, I will erase that. I'll cycle the key on and off again, maybe. Alright, let's cycle the key on and off a few times. Maybe even change gears. Let's see what fault codes it gives me now. All right, that's same fault code is back again. Switch circuit short to battery. So what that means is, guys, when you disconnect this plug, right, what's going to happen is that 12 volt reference is not going to drop. It's going to stay at 12 volt, what the battery, what the computer has sent out. It's a bias voltage, right? So what computer is going to see in the computer is 12 volt. So computer thinks the 12 volt is shorted to battery, means shorted to 12 volt, shorted to positive. That's what computer thinks, because it sees that 12 volt in the computer. So if we had that fault code, right? Now, when you had this connected, right, we also had the same fault code, right? So what that means is there's an open inside this switch. That's what it means right there. Just judging by that fault code when you unplug this switch. Okay. Now, and when I did short that signal circuit to ground, computer gave me a different fault. The computer said the switch failure. So it didn't say short to ground, but a lot of the time you'll see something like that. But this time they only gave me the switch failure. Okay, in the computer programming software, if it's shorted to ground, engineer wrote that description for that fault. Okay, that's just why we're not seeing that. But what it already means to us as a technician, that signal wire is good all the way to the computer, and computer is reacting to it. At this point, you are safe to go ahead and put this new switch. Buy a new switch, put it on, it will work, you'll fix the car. We already know. See, there's already how many tests we did, already verified us that gave us confidence that it needs a new switch. But I'm going to take it furthermore, and I'm going to do more testing, and I'll show you guys what we can do, what we can't do at the switch. Okay, and the reason I want to make this a long video is because not only this is going to benefit for this problem particular on this vehicle, for the four-wheel drive switch, right, but it also going to benefit you for other testing, any other electrical switches, your radio control switches, your AC control switches on the dashboard, you know, on your steering you have your audio, volume up, down, seek buttons, source, menu, on the cruise control, set, resume, cruise on and off, everything, they all work like this, the same exact principle. That's why I wanted to make it a long video, so you guys can tackle any kind of electrical switch. I wouldn't say any kind, some switches work a little bit differently, but most switches I would say on modern vehicle, I've seen they all work this way. Okay, now let's talk about how we can manipulate this signal, how we can bypass this test. Okay, how we can be the switch. Let's say this switch is faulty, right? We can't make it to change nothing, right? If you go to live data, and on the live data we saw on the switch, there's only one anyway, switch status, so short to power, right? That's what we see. Right there, what we can we can't really change that to what we need to be, four-wheel drive, 4L, 4H, because the switch is bad, obviously, right, in this case. But I'll show you how we can be the switch and manually, okay, change that, and we can see the reaction on the computer and be the switch and make the car do what we want to do. Okay, we can do that. Also, one more thing while we're here anyway, let me just see if I short this reference out right here on the connector while we're watching that data. Let's see what happens to that live data. Okay, I'm curious. Okay, I'm gonna short that to ground now. Let's just wait and see what happens there. Nothing's changing so far. I'm pretty sure I'm on the right wire, because I could be I'm pretty sure that was the right wire. There you go. Look at the scan tool. It took a while, but look at the scan tool. Circuit short to ground. Now we can see, we can short this to ground, yeah, with the bridge. We made a bridge here, just jumper wire from negative to the signal wire, to the bias voltage wire, right? Now look at the scan tool. Now I'll pull the bridge out. Now let's see what the scan tool does. It will say it's sorted to battery because now the computer is seeing 12 volt on that signal wire. It's a very, very slow data, I think, on this one. Let me just quickly turn the key on and off again. Maybe that will speed up our process. All right, it says automatic for some reason. Is it because I'm not changing? I have to change the gear? Nope. Let me go back and come back in again. There you go. Now it says short to power. See what I'm talking about? We can always verify that way, and we already know the wiring is good to the computer. Computer is good. It's reacting to the changes we made, right? Now let's take it further. For this one, I'll probably need scope here. So let's grab a scope here, guys. We'll keep that data right there. I'll grab the scope right here. So on the scope, I'll just connect that to scope. Just on that signal wire, or bias voltage wire, whatever you want to call it, on that white with the blue stripe, right? Right now we're seeing 12 volt on the screen, right? You can, and my four-wheel drive switch status is saying power, right? Let's do the same thing again. I'm gonna back probe another wire here on the same circuit, and I'm gonna go give it earth this time. Same thing, I'm gonna bridge it again and let's see the reaction. Okay, let me get that in. Or I can just piggyback that like that. So I'm gonna give earth. I'm just gonna use my battery negative from the cigarette lighter here, just the jumper wire. So as soon as I touch this, see my scope jump to ground. Now let's wait, let's see what the power switch status says. So I just wanted to show you how it looks like on the scope. The exact same thing we just did before, but we didn't have the scope on. I know this video is gonna be long, but I really wanted to cover this with you guys so everyone will understand what I'm talking about. Okay, because not everyone will have a scope, not everyone will have a scan tool, so you can do one way or another way. So basically, look at the scan tool, circuit short to ground, because we're grounding it. Okay, as soon as I pull the ground off, right, it jumps to 12 volt. It will take some time, but that data, live data, will change to short to power. Okay, that's pretty much it, short to power. Now, good thing about my hotel is we can always go to, all right, let me pull that data back up again. Let me go to the waveform generator. Okay, now I just show you how to connect things, but you can look at that later, guys. I don't know why that disappeared, but again, here we go. All right, so here what we can do is we can send voltages, okay, voltages out, any voltage we like. So basically, if I click play here, right, and here I can change. Right now I'm sending 5 volts, 6 volt, okay, 4 volts. I can send any voltages up to, I think it goes up to 24 volts or 12 volts in this case. Okay, it goes up to 12 volt. Anyway, from, let's go back down to, hang on, let's go back down. Let's see what's the minimum voltage this will give me to play around with. Oh, it does go to point 1 to point 1. Okay, it goes from point 1 all the way to 12 volt. Guys, you can do a lot of bidirectional tests with this. Okay, so let's go 12 volt. Right now on my scope, it's not really coming from the scope, it's coming from the multimeter function on that scope, just this J box. Okay, right here, that's your multimeter. That's where you can do all your voltage, all that multimeter function right here. And at the back you got the scopes. You can have 4 channels right here. So from this 12 volt, the red, not 12 volt, the red lead here, we're gonna have that voltage coming out, whatever we want, whatever we select on that waveform generator. Okay, all right, so on the tip of this I can control what voltage I want. So right now we got 12 volt, we're sending out 12 volt right here. Okay, now I can show you I got 12 volts on the multimeter quickly. Okay, so I'll just touch that there and I'll just connect this to battery negative real quick. Okay, I got my multimeter. Okay, right here you can see I got 12.31 volts right there, if you guys can read that. Okay, now I'm gonna go there on my waveform generator and I'm gonna change that, and you can see the voltage coming down on the multimeter. So on this tip I can control whatever voltage I want. Okay, that's all, that's the point I'm trying to make, guys. Now what I'm gonna do is my ignition is on, right? I'm gonna short this out. Okay, I'll just piggyback that, same thing. I'm just gonna put that voltage in that signal wire. Everything disconnected, switch is not there anymore. Now you're gonna become the switch here. Okay, guys? All right, so 12 volts goes in. Not 12 volts, sorry, I got 6 volts showing here. I think, yeah, we changed that voltage before when I was showing you the multimeter reading. So I'm gonna go 12 volt, right? And let's see what my 4-volt drive switch does. We saw the reaction was very, very slow. So just give it some time and let's see what happens here. Let me drop it down to maybe 10 volts. So I'm giving 10 volts right there. See, my 4-wheel drive switch status changed to 2-wheel drive now. Now it's like me selecting the 2H. It looks like around 10 volts it does that. 2H is a 10 volt. Okay, so what's happening right now is computer seeing 10 volts at the computer sensing circuit. Because we are putting 10 volt here, computer thinks yes, the switch has selected 10 volt, and 10 volt means 2-wheel drive. In this case, 2-wheel drive position for the computer. That's how they program the computer. The software is like that. Okay, now let's drop it down. Let's see, let's go maybe 8. Let's drop it down 2 volts. Okay, if you guys watching my waveform generator here, I just dropped that down to 8 volt. You can see down here in the right hand corner. Let's wait because the data is slow. It's a little bit frustrating, but let's just wait and see what happens. Doesn't look like that's doing much. Let me just drop another volt, maybe 7 volts. I heard something click underneath, so it's showing me 4-wheel drive high now, 6 volt. Okay, as soon as I went to 6 volt, it jumped to 4H. Now the computer thinks I'm selecting that 4H on the switch, right? Now let's drop down another 2 volts maybe. See, as soon as I dropped to 4 volts, it went to 4-wheel drive, low. So computer thinks now this is what I'm selecting. I can change all of that here. And I already heard something clicking underneath on the transfer case, I would say, front D for transfer case. So we know everything is reacting to the way we wanna see, right? So now we know 4 volt is for low, right? It was 6 volt for the 4H and it was 10 volt for the 2H, right? Let's go back up. Let's do the same thing again. 6 volts, 4-wheel drive high on the scan tool, you can see on the left. Let's go 8, sorry, it was 8 volt, 8 volt, 9 volt. Yeah, 8 and 9, same thing. 8 or 9 volt is a 2-wheel drive. See, we can manipulate that signal all day long and you can see clearly on the scan tool. Everything else is good. Change the switch, we're done. All right, guys. Is there anything I need to talk about? No, that's it. What I probably would like to do is I may want to have a look. I'll pull it apart because we already saw some corrosion in there. Like, I'm gonna pull it apart and see if I can clean this. Okay, I'll be back, guys. Just give me 2 seconds. All right, guys. Show some light here. I'll just pull this switch apart. Just comes from inside here, 2-piece, right? I saw a lot of corrosion in there. I don't know if you guys can pick up that, but there's a lot of green stuff. Lot of corrosion in there, guys. So looks like to me it works. It's a very simple design, guys. So I just gave it a quick clean with a screwdriver as well, as much as I could, right? Clean the contacts. It was just full of corrosion. So in that let me just change that brightness. See, in that board you got one big contact and there's 3 other contacts on the other side, right? On the other part of the switch, this one at the top, you got 2 contacts. So what happens is it's the same principle. We got 3 contacts for 3 different positions, and the other side is going to have the reference voltage on that big stripe there, one long stripe. On the other 3 contacts on the other side is 3 different positions, and this, when you're turning the switch like this, right, see that turns, this is going to just pick the different position. That's it. And I'm pretty sure there will be register to drop that voltage down to, like we saw on the scan, to like 9 volts, 6 volts and 4 volts, something like that. Okay, guys, so I gave it a good clean as much as I could. I don't know if it's gonna work or not, but I'll put it all back together and see if we can fix this. Okay, guys. It's pretty simple. You just push it in. You just gotta find the right sort of location. Yep, so clicked in. Let's put it in and let's see if we can do this. Okay, all right, I'm just gonna take that voltage supply out. We don't need that anymore. I'm still connected to my scope, so let's go back to the scope. Let me grab the scope here, oscilloscope. Let's go plus minus 20, which is good. Right now I'm showing 12 volt on that bias voltage, right? The signal voltage, signal wire. I'm just gonna connect that now to switch. Okay, let me flip it around this way so you guys can see. All right, as soon as I plugged it in, guys, you can see on my scope I got some activity happening right now. As soon as I plugged it in, it dropped to almost just above 8 volt, just around 8 volt there. And you can see on the scan tool it just jumped from sorted to battery to 2-wheel drive. Okay, now let me go to 4H. I can hear something clicked underneath the car, and scan tool has selected 4-wheel drive, and it's around 7 volts I think on the scan tool, somewhere around 7 volt there. It dropped to 7 volt from 12. Okay, now let's go to 4 low, and it went up to 12 volt. Okay, I was expecting more like 4 volt because we did that test before. So something's still wrong here in that contacts, I think. So now the scan tool is saying short to power, right? I'm just gonna wiggle that switch a little bit and watching the scan tool. Now I dropped that, just wiggling that switch, I dropped it down to 4 or 5 volt. And let's see if my scan tool will show me 4L. Short to power still. Let me go back and come back again. Now it's saying automatic for some reason. Let me cycle the key on and off quickly. All right, cycle the key on and off. All right, 2H, let's go 4H. I'm seeing that voltage drop. See 4-wheel drive high at around 6-7 volts. Let's go down to, it's a little bit, that switch is a little bit bad, so I need to sort of wiggle it around. Now it's dropping around 5 volts and I'm showing 4-wheel drive low. Let's go back. That's 7 volts, 4 high. Let's go back to 2H. That's 2-wheel drive. So I think just someone spilled a drink or something in there. Whatever happened, the corrosion did some damage there. This switch is not in the best condition, but it kind of works now. Just that last position, the 4L, is a little bit not right, but yeah, that 4L position is a little bit still bad. But anyway, customer's gonna need a new switch. If you got the same problem, guys, you can always play around, right? Maybe that might work for you, but this third 4L is definitely not doing its job. I can make it sort of happen, but I gotta wiggle it, find the right position. But 2H working fine. 4H working good, and it's working now 4L. So it's intermittent. There's something wrong with the circuit board, a lot of water damage or whatever happened there, guys. Now also let's see on the scan on this let's go back to 2H, just the 2-wheel drive position here. We can see on the scan tool 2H, and all the messages from the dashboard, all that green 4-wheel drive light, all disappeared, guys. I just got to move that camera to show you, but I'm not gonna worry about it. I promise you, all the lights, everything is gone from the dash, and we can see on the scan tool everything is working. There should be no fault code. If you go back, I don't need the scope anymore. Let's go back to my trouble codes. We may have to clear that all fault. Okay, let's clear that fault, and let's see if any fault codes come back. I don't think so, guys. All right, let's read the fault code. No lights on the dash. I'll just quickly start the car and change the gear. No fault codes. Start the car, change the gear, go drive, neutral, reverse, whatever, and there is no lights on the dash, guys. Let's read the fault code again. I'm pretty sure there's gonna be no fault code. There is no fault code, guys. All right, that's a fix, guys. Okay, but definitely I'll recommend the customer to buy a new switch. But yeah, I think we learned a lot today about electronic switches, guys. I'll catch you next time. Let me try and explain to you a bit more on the board here, guys. About the same system, same switches we just tested out. What's going to happen is you got a ECU. Let's say this is your engine computer in this case. Doesn't matter. This principle will work with any electronic switches, so it doesn't necessarily have to be ECU. It could be radio control module, cruise control module, transfer case control module, whatever the case is, whatever it's controlling, doesn't matter. In this case, we just say it's an ECU because in this car we had ECU, right? So what's going to happen here is you're going to have 12 volt source at the computer, right? 12 volt. So 12 volts going to come, right? And there will be a resistor in there, okay? And then that 12 volts going to travel all the way out to our switch, right? Let's say this is our switch, right? This is a switch, right? So there was 4 wires, 2 wires for lights, okay, backlighting for the, when you turn the headlights on, they will light up. So we disregard that. Only 2 more wires, it's for the computer control switch, okay? So what's going to happen is it's going to have, let's say a resistor here, okay? Now, also the computer is going to send what? A ground, okay? Computer is going to send a ground out towards the switch, right? And it's going to connect to the switch like that. Also, inside the computer, you're going to have a sensing circuit. It's kind of like a voltmeter, okay? It's kind of like a digital multimeter. Anyway, so let's say this is your digital multimeter. So digital multimeter going to have one lead going to here and one lead going to the earth, okay? Now, this is going to read any voltages in these legs where it's connected to. So they put this between 2 resistors because it needs to know the voltage changes. If there is no resistor here, let's say no resistor here, you will never see the voltage changes, okay? So let's say if you connect this to battery directly, this is going to see what? 12 volt all the time here, 12 volt all the time, okay? Now go and watch my other video about coolant temperature sensors. The temperature sensor, sort of I explained to you on the board and show you some practical as well. Go have a look at that video and you'll know a bit more about it. It's exactly same thing how the coolant temperature sensor works. No difference whatsoever here. All right. So that's why you need a resistor inside the computer, okay? It comes through the resistor. I don't know what ohm, what, I don't care. We know there's a resistor in the computer. Now, this is our switch, right? So, in this case, we had 3 switches. Doesn't matter. This can work with 5 switches, you know, 2 switches. Doesn't matter how many switches, how many positions are there on the switch, it does not matter. They will work all the same. In this case, there was 3 switches, means it's going to have 3 resistors, right? So let's say this is a resistor A, which is for your 4-wheel drive low. So 2 low. So okay, this is a 2L resistor. Okay, so every time you select 2L resistor, this resistor is getting selected inside the circuit board. So what happens is, and we saw on the computer, I don't know what resistance it has. We can always calculate and come up with a number, like you can use Ohm's law and whatnot, but we are not interested in that, okay? We know there's a resistor in there. That's all you got to know, okay? Now, what's going to happen here is when you select the 2L switch, this is going to drop that voltage to something, okay? So when you had the open circuit, means if you open circuit, when you disconnect this wire right here, when you disconnect the plug, and that's what the fault code was, voltage shorted to battery, means here it was seeing 12 volt, okay? That's what it means. 12 volt means it's shorted to battery, okay? Why is it seeing 12 volt? Because there's no path to ground. 12 volts going to come in, you're going to have 12 volt all the way to here, and it's never going to see your ground. So you're going to see 12 volt in the sensing circuit. The computer is seeing 12 volt, right? Now, when we shorted that to ground, okay, we put a jumper lead there, shorted to the ground. What's the sensing circuit going to see? 0 volt. And computer knows that it's shorted to ground because it's a 0 volt, because we're dropping all that 12 volt to ground. Okay, because this ground's going to travel up this way, right? Obviously, we have this disconnected. This ground's going to travel all the way up, and here, what you're going to see up to here, ground is going to see 0 volt all the way up to that resistor, right? Now, that's where the fault code came from. Now, to really make the switch work, when you select 2L, this is a X ohm. I don't know what ohm resistor it is. Let's say it's a X ohm. All right. So X ohm resistor is going to drop that voltage to some kind of level. Okay. In that case, we saw it was around 9-10 volts. So what's computer is going to see here? 10 volt, because these resistors dropped some voltage, and we are at 10 volts. So between two resistors, it's going to have 10 volt. Okay. Now, let's say this, when you select another resistor, which was your four-wheel drive high, sorry. So let's say this is a four-wheel drive high resistor now. Different resistor, a little bit bigger, I guess, a little bit smaller, whatever the case is. And let's say this is a Y ohm resistor. I don't know the value. Let's say Y ohm. When you select the four wheel, what's going to happen? And as we saw on the scope when you were testing before, this was dropping to about 6 or 7 volts, right? So computer sees 7 volt in that sensing circuit because that resistor has dropped some voltage, and now it's 7 volt between two resistor. Okay, then same thing again. There was a four-wheel drive, that was four-wheel drive high, now this is four-wheel drive low. Now let's say this is a four-wheel drive low resistance, right? So let's say this is a XYZ G ohm resistor. Okay, I still don't know what value that resistor is. Regardless, now that resistor, adding that resistor to the circuit is going to drop that voltage to a certain level. Now what's the computer seeing? And as we saw on the scope right before, was dropping down to about 4 volts. That's how the computer knows when we're selecting high, low, you know, two-wheel drive, four-wheel drive. Computer knows that because these 4 volts, 7 volts, 10 volts, 12 volts, 0 volt. See, 0 volt is shorted, right? 12 volt is open. There is no path to ground. 10 volt is two-wheel drive, 2WD. 7 volt was four-wheel drive high, and 4 volt is four-wheel drive low, right? Now 4 volt, 7 volt, 10, 12, 0 volt. Computer, the engineers has put that software, put that coding in the computer, so computer knows when I see 4 volts means 4 low, when I see 7 volts means 4 high, when I see 10 volts means 2 WD, and when I see 12 volt is shorted to battery, and when I see 0 volt is shorted to ground. Okay, in that case the scan tool was showing us the switch malfunction or failure. Anyway, that's how they wrote that program. That's what we're seeing on the scan tool. Okay, that's how the computer knows what switch you're selecting, what you want to do, and as a driver, what do you want to do. And let's take this all away, right? Let's take this four-wheel drive, two-wheel drive all away. Right? And let's say this is your cruise control button, cruise control switch. And in a cruise control switch on the steering, you're going to have 1, 2, 3, 4, usually 4 buttons. Cruise on, cancel, resume, and set, right? Let's say 4 buttons, right? Same exact thing. every button on the cruise control is going to have a different resistor, and exactly same way they're going to drop that voltage, and computer is going to know exactly what it is when you're pressing that button using the same fundamentals. Computer is going to know. Now some switches will have 12 volt coming in, some switch will have 5 volt coming in. Okay, some switch could have 9 volt coming in. It doesn't matter. This bias voltage is going to be whatever, doesn't matter, whatever the manufacturer chooses to put it there, it's there. But the principle is exactly same. Okay, exactly same. If it's a 5 volt, they put a resistor, maybe it will drop to 4 volt, 3 volt, 2 volt, 1 volt. So let's say you got 4 switches on the cruise control. So one, let's say, excuse me, when you select cruise on, you're going to have maybe 4 volts. When you select cancel, maybe 3 volts. When you select set, 2 volt. When you select resume, 1 volt, something like that. I'm just giving you an example. You can use all this testing, everything I showed you today, on any electrical switches, and you can manipulate and you can do your testing, bypass testing, actuation, everything at the switch itself. Okay, and from there, obviously, if you got a problem with the wire, you're gonna chase this way, you know, towards the computer and the wiring. But most of the time, more than likely, the components is faulty. Okay, in this case, it was. All right, let's say you got a same fault code. Like we said, we had an open, right? It was showing 12 volt at the sensing circuit, and our resistor was bad. Right here, our resistor was bad, the switch was bad, so it was never making a path to ground. That's why it was seeing full voltage at the sensing circuit. Computer gave us a fault, battery shorted to battery, the switch is shorted to battery. Now, let's say the switch is all intact, everything is working. If you have a broken wire right here, what's going to happen? What's going to change here? Nothing. Computer is going to still see 12 volt, right? 12 volts going to come in through the resistor. There's no path to ground. Computer is still going to see 12 volt, and it's going to still give you the switch shorted to battery. It's still the same fault code. Now, in that case, if you disconnect the connector right here and you saw ground, yes, test light lights up, you saw ground, and you put your meter, and right here you see nothing. Okay, disconnect from the switch, obviously you saw nothing, 0 volt, nothing, right? If that to happen, then you're going to have to chase this way the problem. There's a broken wire, or the computer is not sending that reference voltage out, 12 or 5 volt, whatever the case is. Or the computer could be bad, something wrong in here, so you're not getting that reference voltage out at all time. Okay, now let's say something wrong with your let's say you got a problem with your earth wire. Okay, your earth wire is broken right here, right? Same exact thing. Disconnect the switch, check if there's a 12 volt present there. Yes, there's a 12 volt. Check here, is there a ground? No, there is no ground. The test light doesn't light up, means there's something wrong this way. Now chase that ground wire. Now you really need maybe wiring diagram, see where this go to, service information, you know, and do they change color at the computer, you know, whatever the case is, you check that way, right? Now, if that's the case, I would probably go directly at the computer, find the pin out on the computer, which wire is that, and check the earth right here. Does my test light light up? Yes, means there's a broken wire between here and the switch, right? Same thing for the top. If the top wire, the reference wire was broken, same thing. If you check the power right here at the computer, if there is 12 volt present, means the problem is the broken wire this way, right? If you see if you see nothing, no 12 volt here, right? No 12 volt, it's not shorted to ground, means more than likely the problem is the computer itself, right? Okay, now another scenario. Another scenario is the scan tool showing it's shorted to ground, or in this case the switch failure, something like that on the scan tool description when we short this wire together, right? Now if that to happen, and as soon as you unplug this, right, the fault code changed to now shorted to battery, right? Because it was 0 volt here. As soon as you unplugged it, you fixed the short, right? Now it jumped to 12 volt, and the fault code description changes, means the switch is the problem. It's shorting that circuit to ground. Now if that didn't change nothing, it's still showing you shorted to ground, means there's some short in the wiring harness somewhere here, or this could be touching to the ground. It's shorted somewhere, so you're going to have to follow that way and chase your problem, right? Now you can always go to the computer if there's a short. Always go to the computer, and you can always disconnect the wire right here. If you disconnect that wire right here, let's say there's a short right in the wiring harness between two wires, okay, whatever the case, or this is touching the body, whatever the case. You are seeing what here? 0 volt. Computer knows it's shorted to ground. You disconnect the sensor, this didn't change because short is here, not in the switch, right? Or coolant temperature sensor is exactly the same way how they work. So you're going to see 0 volt here. Computer knows it's shorted to ground. You disconnect that sensor, nothing changed. Fault code didn't change, still sitting at 0 volt, right? Fault code description is still the same. Now go to the computer, right, and cut this wire right here, right at the computer. Obviously keep some length so you can solder it again. Cut that wire. Now what's going to happen? If the short is there, this is going to change to 12 volt, because 12 volts come in through the resistor, no path to ground. Means the problem is between here and here. There's some short between the wires, right? Wires between the computer and the switch, right? That's it. I mean, anything I'm missing here? I think that's pretty much it, guys. Hope you learned something today. I'll see you next time.